Okay, so we are going to pick back up with how to balance chemical equations. And as I mentioned, there are 4 rules we're going to use to help guide us with balancing. So here's rule number 1. You need to correctly write the unbalanced equation. Okay, so we need to use correct formulas. And one thing I want to bring up, in chapter 4, we introduced that some molecules exist naturally as a diatomic molecule. And it's going to be very important that you remember how to write those correctly. So how do we write diatomics? Well, the 7 elements, there was hydrogen and then nitrogen and oxygen, fluorine, chlorine, iodine, bromine. Okay, I think 1, 2, 3, 4, 5. Yeah. So how do we write these? We don't write them as single atoms. We write them as, for example, H2 or O2, okay, as 2 bonded atoms. So make sure you do not write them as single atoms. You write them as a bonded molecule, 2 atoms bonded. All right, so for example, let's read this statement and let's write the equation properly. If we have hydrogen sulfate and it reacts with sodium hydroxide to make sodium sulfate and water, how do we write this? We have to get the formulas correct. So you're going to need to remember the rules for naming ionic compounds and binary compounds, covalent binary compounds. So hydrogen sulfate, this is hydrogen is the cation, sulfate is the anion. Remember, sulfate is SO4 with a -2 charge. Hydrogen is a group 1, so it would be a +1 cation. So how many of each do we need to make a neutral compound? We're going to need 2 hydrogens, all right, and we're just going to need 1 sulfate. Remember, you can always do what we call the switch trick. Look at the charges. That tells you how many of the opposite anion or cation that you need. So we need 2 cations, 1 anion. We're going to write it like this, H2SO4. All right, that's hydrogen sulfate. Reacts with sodium hydroxide. Remember, sodium is Na+. Hydroxide is OH-. We got a +1 cation, a -1 anion, so we just need 1 each in our compound. All right, so there's our reactants, and they make sodium sulfate. All right, so basically the cation from our second reactant now is bound with the anion from our first reactant, so that should be Na2 because that's a +1 cation, so we need 2 of them to balance a single -2 anion. We don't write the charge, sorry. That's all we have. Okay, 2 sodiums, they're each +1. 1 sulfate, it's a -2, so these balance to 0. Or that's a neutral compound. And then water, we know what water is, H2O. All right, so we have written these correctly. Now let's read what the next rule down here on this slide is. We need to add up the atoms on each side, and then we'll add coefficients to balance. So once you have your equation written correctly, now you begin the balancing process. And there's a note. Let's read this note. It says polyatomic ions can be treated as a single unit if they occur on both the reactant and product side. Okay? If they're in both a reactant and a product. So, for example, looking at this equation, we have sulfate as a reactant and we have it in a product. So we can treat it as, we don't have to separate the sulfur and the oxygen and balance those elements separately. Now we have hydroxide over on the reactant side, but we do not have it on the product side. So we're going to have to balance oxygen and hydrogen separately. Okay, we'll treat sulfate as a unit, but then we will also have oxygen by itself, and we'll have to balance that as an element as well. So what I like to do to balance these, to go about balancing them, is I write out all the elements or all the polyatomics that I have. So I have hydrogen is an element on both sides. I have sulfate, SO4. I have sodium, and I have oxygen. Okay, this is all the stuff that I have in my equation. And then I write, I put little dashes on each side, and I'm going to indicate how many do I have on my reactant side and my product side. Well, on my reactant side, I have 2 hydrogens. On the product side, 3 hydrogens. 3 hydrogens. And on the product side, I just have 2 hydrogens. All right, sulfates, I've got 1 sulfate on either side, each side. Sodium, I have 1 sodium on the reactant side And I have 2 sodiums on the product side. Oxygen, I've got 1 oxygen. Remember, these oxygens over here are part of sulfate, so I don't have to count those as just oxygen. Those are counted as sulfate. So I have 1 oxygen on the reactant side, and I have 1 oxygen on the product side as well. So now we look at how do we go about balancing this. So it looks like I'm going to need double the sodiums on my reactant side. I've got 2 on the product side, 1 on the reactant side. So I'm going to balance with a coefficient. Really, there's no exact strategy on how we go about this. We are just trying to get the same number on either side. And I see I need double sodiums. So that, I'm on the eraser. That should be fixed if I put a coefficient of 2 in front of sodium hydroxide. Now I have 2 sodiums on the reactant side, 2 on the product, okay? Now the only thing that's not balanced, well, let's recount my hydrogens. When I put a 2 here, not only do I have double the number of sodiums, I now have 2 oxygens. So I need to change this down here to a 2. 2 oxygens, and how many hydrogens do I have total now on the reactant side? I have got 2 over here, and this 2 applies to that hydrogen, so now total that's 4. So one number can change a lot of things. Okay, so now sulfate is balanced, sodium is balanced, and what I notice is that I have double the number of hydrogen and oxygen on my reactant side compared to the product side. And what's nice about that is I have hydrogen and oxygen all together on my product side in the molecule water. So if I double the number of waters that I have, I'm going to double the number of those elements, which is what I need to do. Now I have 4 hydrogens. This 2 multiplies hydrogen by 2, so that's 4 hydrogens. Now hydrogen is also balanced, and now I also have 2 oxygens. So when I look at this now, let's see. Everything is balanced, okay? Hydrogen 4 and 4, sulfate 1 and 1, sodium 2 and 2, oxygen 2 and 2. Okay, so that's balanced. So rule number 3 is double check the balance, which we just did, and then you need to make sure that you reduce coefficients to the lowest whole numbers, okay? So if I look across the board, what coefficient do I have right here? I actually have a coefficient of 1. We just don't write it in, okay? There's an understood 1 there. And then I have a coefficient of 2 in front of sodium hydroxide. I have an understood coefficient of 1 in front of sodium sulfate, and a coefficient of 2. Now because I have these coefficients of 1 in front of hydrogen sulfate and sodium sulfate, I'm as simplified as I can get, okay? So we do have our lowest whole number. Now if I had 2, 4, 2, 4, I could simplify that, right? Everything's divisible by 2. But I'm already simplified, so essentially rule number 4 here, we're already there. So that's the final balanced equation. All right, let's try another one. We have CH4, Cl2, so we have if you have watched the video on how to name binary compounds, this first reactant is carbon tetrahydride, and we have chlorine. Remember, it's a diatomic, so we write the 2 in right there. Then we have, this is not a binary compound on the product side, we have a carbon with 2 hydrogens and 2 chlorines, and then we have HCl, hydrochloric acid. So I don't have any polyatomics, so I don't have to worry about grouping them as a unit or if they're on both sides or anything. So I'm just going to write my elements. I have carbon, I have hydrogen, and I have chlorine involved in this reaction. On the reactant side, I have 1 carbon. On the product side, I have 1 carbon. I have 4 hydrogens over here. I have 3 hydrogens on the product side, 2 here and 1 here. Chlorine on the reactant side, I have 2. On the product side, I have 3 total. Okay, you're looking at the total numbers between all the reactants and then between all the products. So now how can we balance this? Well, I can see that I have more hydrogens on my reactant side and I have fewer on the product side. Also a tip, okay, a tip. Balance, oops. Elements by themselves last, okay? Elements that are by themselves, balance them last. So I'm going to balance chlorine last because I can put a number in front of chlorine without messing anything else up. So I notice my carbon's already balanced, so I don't want to balance carbon. So I'm going to start with trying to balance hydrogen. And I notice that if I put a 2 right here, what is that going to do to my total number of hydrogens? Well, now I have 2 right here, and this 2 applies to that hydrogen. So now I have 2 more. 2 plus 2 equals 4 total. So that means I have 4 on this side. And what do you know? Now hydrogen is balanced. What did that do to chlorine? What that did to chlorine is that it gave me another chlorine on the product side. So I went from 3 chlorines, now total I have 4. All right, 2 here and 2 over here. So I have double the number of chlorines on the product side, so I need to double the number of chlorines on my reactant side to get those to be balanced. So if I put a 2 right here, now guess what? I have 4 chlorines on each side and I'm done. That was easier than I thought it was going to be, okay? Then you double check the balance. Okay, doing this stuff right here helps you double check that we are balanced. And do we have the lowest? Rule number 4, remember, was can we reduce our coefficients? Well, I have an understood 1 here, and then 2, and then an understood coefficient of 1 right here in my first product. And the 2, because I have these 1s, I'm as reduced as I can get. You can't divide and still get a whole number since we have these 1s. So everything's good. Let's do another one. Let's keep going. The way you get used to balancing, the way you get good at it is you just practice. So we have aluminum hydroxide is our first reactant. Aluminum hydroxide. And then we have hydrogen phosphate. These react together and make aluminum phosphate and water. So I notice that I have 2 polyatomics. I have hydroxide and I have phosphate on the reactant side. On the product side, I have phosphate, but I don't have hydroxide. So what that means is we will balance oxygen and hydrogen separately, but we will keep phosphate as a unit since I have it on both sides. So I have aluminum, I have oxygen, I have hydrogen, and I have phosphate. That's all I have. So now let's start to try to balance this. I don't have any element by itself, like my tip up here noted. Sometimes you will, sometimes you won't. Let's count up where we're at right now. So I have 1 aluminum on each side. This 3, remember, it applies to both oxygen and hydrogen. So I have 3 oxygens and I have 3 hydrogens. Nope, I have 6 hydrogens. How do I know I have 6? Well, I've got 3 in my first reactant, 3 over here, 3 and 3, that is 6. Phosphate, I just have 1 phosphate. How many oxygens do I have on the product side? I just have 1. How many hydrogens? I've got 2 and 1 phosphate. Okay. So how can I balance this? Well, here's what I noticed. Aluminum and phosphate's already balanced. So I do not want to put anything right here as a coefficient because that would throw my balance off. So I have 3 oxygens, 6 hydrogens. Here's what I notice on the product side. I need to triple my number of oxygens and hydrogens. If I can do that, everything will be balanced. So if I put a 3 right here in front of water, what does that do? Let's just see. Sometimes it's trial and error. Well, now I have 3 oxygens. That balances. And then 3 times 2 gives me 6 hydrogens. And I did not expect it to be that simple, but everything is balanced now. Okay, so I double checked that I'm balanced. Oh, I just erased my coefficient. And am I reduced to my lowest whole number ratios for coefficients? Well, I have a 1, 1, 1, and 3, and I cannot simplify that any further. So yes, I am. And remember, you don't have to write the ones. Okay, there we go. So that's some examples and some tips and some rules for balancing equations. I will give you guys more practice with different kinds of worksheets and things to come. But that concludes tips on balancing. In the last video, we're going to cover types. I think there's 4 or 5 types of chemical reactions we're going to get into.